Okay, YouTube, in this video we're going to be concerning ourselves with degree measurement angles in general and basically the principles behind them. So let's go ahead and consider what an angle is. By definition, we say an angle is just the amount of rotation formed by two rays with a common endpoint, this being the common endpoint right here. So one thing I do want to point out is the amount of rotation, it could be either on this side or it could be on this side. So we have to actually distinguish between which side or the next. And I'm going to go ahead and say that it's this angle right here, some obtuse angle. And I'm also going to point out the fact that there's an arrow on this. Usually, if I were to put an arrow this way, we would be indicating that it rotated in the opposite direction than what it just did, okay? So given this current configuration, we're going to refer to this as the initial side of the angle. Initial side, given the way we've drawn it here. And this will be the terminal side, where it terminates, okay, where it stops. So terminal side. And then the initial side is where it initiates itself or starts. So I will say this. When we draw, angles in the xy coordinate plane, that would be the xy coordinate plane here, one thing that we try to do as much as possible, instead of having this angle here and saying that, look, this is likely, a similar angle, maybe the same angle, it's hard to tell because they're facing in different directions. So perhaps we should all agree that we are going to orient all angles in the xy coordinate plane into what we call a standard position. And essentially, standard position says that the initial side of our angle here is on the positive x-axis, and it always will be if you want this to be in standard position. So we would say in the rectangular coordinate plane, an angle whose vertex is at the origin, so we have a vertex here, and whose initial side is the positive x-axis, we say it's in standard position. So I could draw this angle right here, or I could also draw this angle up here, which I'm going to draw this angle up here, and I'm going to call this an angle with a Greek letter theta. This would just indicate that this is an angle. So now the way I've sketched this, you'll notice that I rotated counterclockwise, and this is kind of an important fact, but our angle is this angle formed by this amount of rotation, these two rays that share a common endpoint at the origin. But basically, a counterclockwise rotation, so we say counterclockwise, this is going to be considered to be a positive angle. So this is a positive angle. Now I know that's, when you look at the clock, it rotates clockwise, and you would think that'd be positive, but actually counterclockwise is the positive orientation. And then if I were to, switch over to, say, a different color here, and we say this green angle right here, I'll even write the text in green down here, but we would call this some other angle here. I'm going to call this phi. It's like a little oval with a slash through it there. We say clockwise is a negative angle, okay? So to be in standard position, essentially your starting point has to be at 0 degrees over here on the positive x-axis. But we say this is a negative angle if it's a clockwise rotation. So given these two things right here, there are 4 angles that we often kind of classify before any of the other angles. We call these quadrant angles or quadrantal. I've heard them called quadrantal before angles. But we say here that the 4 angles are formed between the x-axis and the divisions between the 4 quadrants. So we call these the quadrant angles, and they are respectively 90, 180, 270, and then we should just call this 0 or 360, given that they land in the same spot. So if we wanted to look at the xy coordinate plane, we're always going to, if we're discussing standard position, classify this as 0 degrees, because any angle that's starting here and ending here would have rotated no degrees. But we're going to refer to this up here. We say this angle right here. This is a 90-degree angle. 90 degrees. This would be 180 degrees over here if we were to rotate this way, 180-degree angle. We call that a straight angle as well. And then we say if I were to rotate down here, here's our 90. But rotate down here, this would be 270 degrees, and you could get this just by adding another 90 onto 180 or subtracting, 90 off of 360. But you notice I call this or 360. Often you will see this little statement on problems. We say that the angle theta, whatever it is between 0 and 360. And you'll notice on the 360 I left it as not or equal to, because the moment you get to 360, you've got an angle that does this. It's not the same as a 0-degree angle, but they do terminate in the same spot. So, we could kind of loosely say that, we just need to be able to represent angles between 0 and 360, and then everything else after that is just superfluous. We're adding on things that still terminate in the same spots. So what I want to do before we kind of peace out on this video is essentially this. I want to sketch these angles. And I say sketch, not draw, because we're going to do our best guesses here what these angles look like. But we're going to sketch these in standard position and then tell what quadrant the terminal side lies in, which is kind of an important thing. So 210 degrees. The first thing I want to point out is this. If I'm in standard position, my initial side has to be the positive x-axis. So now I notice this is a positive 210 degrees, so which way we're going to rotate? Well, this would indicate that we're rotating counterclockwise. And then the last thing you want to notice, or at least I want to point out, is this. If I'm going to find 210, what I know is it's beyond 180, but I'm going to use the fact that this is 180 to make my way here. So what I know is it's about 30 degrees past 180. So what I'd rather do, instead of kind of configure where a 210 degree angle is in my head, is I'd rather just look at this 180 and say, well, this right here is about a 30 degree. But we're going to sketch this actual angle, which means you actually need to draw on this green portion. We're going to call this the angle theta, so I'll label this theta as 210 degrees. And another way to label this is to label it out on the end of the vertex here. You could label it this way. So 45 degrees, and a negative 45 degrees at that. Well, when I'm going to rotate negatively, we're going to rotate in a clockwise fashion. And because I know that this is negative 90 degrees right here, well, what do you know about a 45? It's half of a 90. So I'm going to kind of rotate halfway between the positive x and the negative y axis here. And then I'm going to sketch in the angle, which would be this right here. So we say this is a negative 45 degree angle. Okay, and you could also label it out here. All right, so here's our negative 45. Now a positive 510. This is an interesting thing, but 510, that's obviously over 360, and I like to call these, whatever, curly Q's. But essentially, this is going to wrap around one full time and then some. So if we want to figure out, 510, how can I figure out how many more degrees I'm going to have to rotate past one full rotation? Well, why don't we take this 510 and subtract off 360 degrees, and what that leaves behind is this other 150. So we're already familiar with the fact that it leaves over here, and it goes around one full time is 360 plus another 510. So another 510, if this is initially 180 degrees before we rotate it over one full amount, we'd say, well, 150 would be about 30 degrees short of that. So again, we're using this quadrant angle to help us find our way there. But this would be my 510 degree angle right here. Cheers.